Yeah, so this video is on learning curve. So we want to look at this question in particular, the one which is on the screen. So after preparing the cost estimates above, so I'll show you the cost estimates above that they're talking about, the company realized that it has not taken into account the effect of the learning curve on the production process. The variable manufacturing cost per unit above of 40 kwacha in year 2 and 42 kwacha in year 3 includes the cost of 0.5 hours of labor. The remainder of the variable manufacturing costs is not driven by labor hours. The year 2 cost per hour for labor is 24 kwacha and the year 3 cost is 26 kwacha per hour. Subsequently, it has now been estimated that although the first unit is expected to take 0.5 hours, a learning curve of 95% is expected to occur until the 100th unit has been complete. 1. Find the total labor hours for the first 100 units of year 2. Well, this question they're talking about above is right here, which I've actually solved in one of my previous videos. That's life cycle costing. As you can see, Pate was asking for the life cycle cost. So I've solved it in one of my videos on my channel. You could also do to check it out. So here, let's apply the learning curve. So what's happening? Find the total labor hours for the first 100 units of year 2. So first of all, before you can find the total labor hours, you want to first find what would be the average time for 100 units, because you know from 1 unit to 100 there's been some learning that's been occurring. They just said learning stops at 100, so meaning the previous units they've been undergoing some learning rates, and so there's this formula that you use that can just encompass all those 100, because to just take an average time that most likely those 100 units were taking, because there's so many. That's why there's this formula for an average time that probably those units could be taking. So let me share the screen. So take note that our question mentioned that before I get the question, the formula we're looking at is this one. First of all, let's understand the symbols. A stands for time taken to do the first unit, the time that is being taken to produce the first unit. That's A. X, it's what you're being asked for. Is it the 100th, the 99th? You know, that's what X stands for there. Then B is just what we call the learning rate. The learning rate, they say it's equal to log of the learning curve percentage, which is 95, over log 2. That's how you get B. So always remember the learning curve percentage comes to work on B. And as you can see, log of that percentage, okay, just say 95, even when you're punching on your calculator. So this is just going to be log, by the way, when you're punching, just say log of that 95.95 over log 2. So just remember, this is 95%. So now when you're putting it in this formula, just put as log 0.95, then over log 2. That's how you'd write it. That's how you'd convert the 95. Just convert it to decimal. That's the only way you get an accurate B. And the B I'm getting myself is giving me negative 0.074. I can end there, at least 3 or 4 decimal places is fine. That will be your B. Then you just substitute in this formula here. You know, A is the time being taken for 1 unit. They said 0.5. The question mentioned it. X is how many hundreds for the 100th unit, so you put 100 there. Then B, negative 0.074. What answer are we getting? 0.3556. That's just the average time for doing 100 units. That's what this one is showing you, because you picked 100 and showing you, okay, to do 100, the y, which is just standing for the average time to do 100 units, it's that number. But you haven't yet answered the question. They said the total labor hours for the 100 units, the 100. So the 100 units, so this is just an average. So it's just showing that, okay, most likely one was taking 0. What, another one was taking 0, because it's just an average. Now we want to get the total now of all the 100, so just multiply by 100. This is going to even give you 35.56 hours, because it's in hours. That's it. You're done. That's A. To calculate the total labor hours for year 2. How do you calculate the total labor hours for year 2? Take note that we have managed to first find the hours that are being spent by the 100, but that's just 100 units. What about how many units were in year 2? Because you have to find for the whole year. That's what they said, the whole year 2. So going back to the table, year 2 has 100,000 units, if you get what I mean. And they've only done for what? The first 100, meaning how many are left with realistically? So if you count that 100,000 minus 100, you should get 99,900 units left that have not yet been accounted for to also find the labor hours. So what you can do is that since learning has stopped on 100 and you cannot keep on applying the learning curve onwards, what you can do is that know the time that this 100th unit is taking, because it must be known that the others will all work at the time that the other one stopped. You can see the logic. If learning, let's say, ends on 100, like though they've said it, meaning the 101 units, the unit number 101, will work at the time of the 100th unit, because it's like learning has stopped, meaning time will now be fixed, if you get what I mean. So what we want to do is want to determine the time at the 100th unit, the individual time of the 100th unit, because that's what's going to be seen throughout, because learning has stopped. Time will not keep changing. That's how you should understand this. That's how you just always, so take note on the period when learning stops, and then you say, oh, we've actually even got extra units. Like in our case, we have 99,900 extra that also need to be accounted for, and we need to know what time we'll put on them. So we need to know the individual time of the 100th unit. Once we know that, we'll be able to apply it to the remainder 99,000 there. So what I'm going to start is, as I've said, is let's find the individual time for the 100th. So how do you find the individual time? Take note that we would find first this average time at the same 100 itself. These are the procedures, just understand them the way they are. We'll find the average time, the way we computed, which was 0.3556. Find the total time at the 100th, which is the 35.56. These are the procedures. Okay, once you do that, find the time also for the previous units, which is what? 99, because it's the one which is just before. Because this is a procedure to find the individual time for whatever you're looking for. So we're looking for the time for 100, but to do that, they are supposed to find the total time for 100 units, which we've already done in part 1. Then the next step is also find the total time for the units just below it, which is 99. Once you do that, because what I'm just showing you, these are shortcuts to make your life easier. Yes. Then once you do this one, it's giving you so 0.3558 7, yeah. Then times 99. Also, it's find the total time for the 99 as well. That's what you should also do. This is going to give you 3558 or 559. Yeah, if you want here in this case. Yeah, then you just do that. So once you do that, in fact, this one is going to give you 3523. I beg your pardon. That's the total time for the 99. Then once you have the total time for the 99, subtract from the total time of the 100. It's even going to give you 0.33 as the individual time. So that's how you find the individual time. After you find the individual time, you can now apply it from the remainder units. There are about 99,900 units left. Once you find that individual time, it's being applied to each other unit that is following after 100, and they all have the same time. Once you do that, it's going to once you do this, to give you the time for those 99,900, and then you can even add on with this one that you've already done, because the first 100 have already been accounted for and they have that time 35.56. Then when you do your calculations, you're even going to land with this as the total labor hours for everything in year 2. Done. Number 3 is saying calculate the labor hours for the 100th. Take note of the way they phrase this, the 100th unit. So that same 100th unit, what would be the labor hours for that one? So basically, we're going to use that same formula that we did. In fact, won't even got the formula. The 100th unit, that is the in short, when they even put that TH symbol, they're just asking for the individual time for that 100th unit, which is what? Well, just from even calculating it, 0.33. That's the individual time. So those are the hours, unless if they said total would have started multiplying times 100 to now get everything for 100, but they just said for the 100, so that's individual 100th unit. What is its time? And we're just from doing it in parts 2, 0.33. That's the answer. Number 4, calculate the total labor cost for year 2. Total labor costs. Well, we have the total labor hours. This should be straightforward. We have the total labor hours in year 2. We were just from calculating them in part 2. That was 33,002.56. Those are just in hours. Now, how do you find the costs? We have the paragraph given here. The year 2 cost per hour for labor is 24 kwacha. So it should be straightforward. On the next screen, I'll show you. So as I said, if you notice, these things were flowing. Once you just handle, is it 1 and 2, the rest was just falling in line. Trust me. Yeah, it's very simple. So you do that times 24, because this is the cost per hour, and these are hours here. These are hours. Then you see the cost per hour. Yeah, then you get the total labor cost as they have asked for year 2, and make sure you pick the cost in year 2, not any other year. Even put squash because it's a cost. That's the answer for number 4. 5 is saying find the total labor hours for year 3. Total labor hours for year 3. Well, what was, let's say in year 3, how many units were there first? That's what we want to look at. Year 3 had 200,000 hours. Okay, we have to take note of that. And as we have been calculating, the first 100 have already been determined. Now this one has now got 200, meaning how many are left? If you've done for the first 100, let's start from the 200,000 total. You're going to be left with 199,900 left units that have to be accounted for. So what you're just going to do here is that, okay, those remaining units, you can just multiply them by the 0.33, then, okay, I'll show you in the next screen just to make your life easier. So as I was saying, the first 100 have been accounted for, and they gave us a total time of this. Now it's just left to account for the remainder, and year 3 had 200,000, but when I list the 100 so that we can know the unaccounted for units, that's the figure 199,900. Just multiply it by the time for the 100, because as I said, from 100 the learning stopped, so throughout they'll follow the time that the last unit had, and that's the 0.33, so that you can know the total time for the remaining ones. Therefore this is going to give you 66,002.56. yeah, that's your answer there. Number 6, find the total labor cost for year 3. Well, this should now be simple. You now know the hours for year 3. You've just determined them. It's just a matter of multiplying the cost. What's the cost in year 3? Well, year 3's cost is 26 kwacha. That's the one I'm going to apply here, 26 kwacha on that same labor hours that you're just from finding. I did not even erase my hours, so these are hours. Just multiply them by 26. I'm ending up with 1716066.56 kwacha total labor cost for year 3. That's how you also answer that one. We are on number 7. Find the total life cycle labor cost. How do you find the total life cycle labor cost? Well, we now have the labor cost for year 2. We have the labor cost for year 3. We are calculating those two figures, if you recall, and rewind this same video. So those are the figures you're going to get, because they're specifically talking about labor cost, and labor has been determined just from the same calculations we have been doing. So that's going to be these following figures. So you have your 1716066.56 as for year 2. Even year 3, the labor cost was this is year 3, sorry, this is year 3's cost. What about year 2? Year 2 is the one that we found that time as 792,061.44. What are we going to get? So when I add these two, just a minute, when I add these two figures, I'm getting 2508,128. That's my total life cycle labor cost there. Yeah, so just as you should know the concept from life cycle costing, you just add all the costs in each year. That's how you find life cycle cost. It's one of the very simple costing techniques. Number 8, how much saving or additional labor cost does the learning curve of 95% bring to Kanyambi company? How much saving or additional labor cost does the learning curve bring? So what you're going to do is that the learning curve has shown you this labor cost for 2 years. You managed to compare the 2 years. That's giving you that 2,000. That's 2,508,000. And that should be 128 that we had at the end. So once you get that figure, that was from the learning curve perspective. Now what about before the learning curve was applied? Like, what would be the labor cost? This is what I want you to show, so that we can get to see if there's been some saving on the like. So what we're going to do is this. Let's find the labor costs without learning curve. So we're going to say, okay, the time per unit is 0.5. That's what they just said in general, it's 0.5. Then how many units were made in year 2? It was 100,000. Okay, then of course to get the costs you can apply the 24 plus in year 3 there was same 0.5. How many units? 200,000. Okay, then you're multiplying by the costs in there because you're looking at labor costs here, hence I'm doing this. So you multiply your 0.5 there. One of them is already giving you a 1, 2, plus the other side 0.5 times 200,000 times 26. That's 26 this side. So 26 plus 1, 2. What are we getting? 3,800. 3,800. That's like without learning. This is the labor cost that they were incurring. Now, how much did we get with learning? Okay, so without learning, it's that. With the learning curve, we got 2,000. Just a minute. So the other one actually was 2,508, 128. Just subtract, you know, savings from there. Actually, that's how you know that you've saved, because you're just comparing the two figures. 129, 1 million, sorry, 1,291,872 kwacha savings. So this video is just mainly wanting to focus on those first 8 questions there, and generally that was the learning curve part, which has already even been tackled. The other parts were now just checking for savings and the like, but the major part of the learning curve has been highlighted in this video. So just take your time, rewind where necessary, and this is basically the video on learning curve.